Hi. Hello, everyone. Can you hear me?
Yes, sir.
Yes.
Okay, good. Okay, so what I will do first is I've kind of added more details to the task descriptions for the project. And I've also added some information about what the expectation is, what I expect. Okay, and the division of the marks for the project among the different tasks that is expected of you. And, so that I will describe first. And in the process, I also give some information about, what you need to do inside, some technical information. After that, so I can let Diganta add any additional information or take any general questions that you want. And here's what I expect. So this is I have to share. So sorry. What happened? So let's see who all are here. Okay, so the other two are not here. Okay, so maybe they will listen to it, the video. So the the project had three main tasks. What is verification? Yeah. You can be on my desk if you want. That's why. Yeah. Just one moment. Okay. So the first task is, okay, so what I've done is A and B I classify as a single task. Well, so here I've listed two tasks. First is verification of, okay, so it's the question for the chat. You can't seem to see the screen. Oh, okay, because at that time I hadn't. Okay, so everybody can see the screen now, right?
Yeah, I think I still have some problem with it. I'll figure it out. You present, sir. I'll just see what I can do here.
Because at the beginning I had not, I forgot to share it, but now I'm sharing it.
Yeah, I think it's on my end. So you present. I'll just maybe join from mobile. I'll join from mobile. Yeah.
Okay.
So you continue, sir. I'll just join from mobile.
Okay. So A and B I had combined in one task. Now I have listed them as two separate tasks. One is verification of the emulator for what I call as design agnostic properties with EVA. So that involves use EVA with its implicit abstract domains to check if the emulator code is free. So so that so I have divided, and then to confirmation, the other task at the top level is to confirmation all the warnings that you got by running EVA on the emulator with CBMC. That's task B, the second task. Then the third one is developing and kind of in a methodology to formally verify the correctness of the emulator in a way that I will be that I had described earlier in the project description, but I will give some more details here. That consists of two subtasks. One is kind of general verification of the emulator in a way that I will be describing, and then also to verify, certain given pieces of code, okay, whether it is correct with respect to given pre and post conditions as when it is executed on the emulator. I'm reserving 50% of the project thing for these two, for the two subtasks under C. Okay. Overall, since I'm putting, this kind of puts together all the things that you have learned, these project tasks in the course of the course. Okay. So, as you know, the significant percentage of the grade is allocated. I think it's about 40% to this project. Now, if you're not able to, I don't know what the status of your progress is, and hopefully I'll hear about that, after I'm done with my part of presentation. But somehow I feel, of course, this is my own gut crunch, that if you're only able to do A and B part of the task, I mean, you can't expect anything more than B grade in the course. For you to get an A, I expect that you should at least do a significant portion of C, okay? Because I'm reserving 50% of the grade for that. Yeah, and of course, the B grade that you get if you don't, so which means that I want you to do B and C if you want an A grade in the course. Now, if you don't do B and C, and if you want to do only, are able to accomplish only A, that B grade will depend on whether how well you do on the rest of the things, which will include the 2 assignments and the take-home exam that you have. Now, in order to ensure that that I don't know, this all depends on how well I'm willing to extend that. If you choose to take this option to the project deadline to 20th, that is 1 week after what I had announced as 13, you can take till the 20th, May 20th, to submit the thing. But if you choose not to submit whatever that you can by the 13th, then that is your choice. But that is roughly what I will do. Of course, I will evaluate whatever that you submit, whenever you submit, whether it is 13th or 20th, we will evaluate the thing, and I will try to get the grade for the assignments, before the 13th, and hopefully within the next few days. So you will know how well you are, you have, performed on the 2 assignments. And of course, the final exam, I will try to get it graded. And of course, because it is, we agreed the final exam to be given out 10th to 12th, correct? So that is the date.
Siddhant.
Excuse me?
Siddhant has exams on both days, so he was asking for 9 to 11.
Oh, 9 to 11th is what we chose. Okay, so 9 to 11 then, yeah. Okay, and yeah, so you have the option of either submitting it on the 13th or the 20th. Okay, but the rough parameters is as follows. So that, like I said, I expect you to at least take do an honest attempt at C. Okay, and then just don't expect, because this is just, it's no relative grading, it's a small class, so I will be just individually grading the thing, and my expectation I have described, I have presented. So any questions?
So me and Siddhant have been trying to do the EVA and CBMC task, and we feel like this is like infeasible. So what happens is the code is really small. It's 8086 tiny, but the reason it is small is because there are like hundreds of hash defined macros. And when we try to expand that, there is like a single main function that 1500 lines long, and like every error, everything is inside that function. And like when we tried even with one assert at like unwind depth 4, CBMC takes up like all of my RAM, like 16 GB, and immediately crashes. And that's with just one assertion, and we couldn't
Okay.
even add more.
Yeah, no, I think if indeed you say that, that's why I said the outcome will depend on, how the thing is. So I want you to have attempted B and C. If generally there is a lot of issues, we will look at it jointly and, calibrate what is, what the outcome would be. Now, so what you're saying is that how much, okay, let me describe what I want you to do, okay, and see what the technical issues inside there might be, and then see if we can, there is a way to get around it, okay, and, so then we'll do. So now, let's take this A is pretty much, so Eva does not have any problem in.
So I would say for
what do you have?
The problem is like identifying the parts of. So when we expand the macros, they generally become like there are like a billion casts and there are billion pointer manipulations that I think become like too confusing without the comments. And without expanding the macros, they are like one-line definitions. So, I can actually show the code later in Diganta's part, I guess.
Yeah, okay.
He should also have a copy of my code.
Sure. So let's take that. And so as you can see, the analysis of the error warnings, I have scaled it down to not, to only a small set of warnings, okay? Maybe we could use those, direct those warnings. I've identified about 10 warnings inside each of them. We can reduce that even to smaller. So I want you to pick one, few warnings in each of these categories and, analyze them, okay? If it is all of them are coming inside some other macro, then those details we can see. So what I've done is I've scaled the number of warnings that you need to analyze to a smaller set, okay? And we could jointly look together what those warnings are, where they occur, and make them more feasible to be analyzed within CBMC, and then understand what the technical issues that you're facing are in running EVA, and what would be, I know that the technical things with CBMC would be in determining the number of unwindings that you need, for the loop. This one, the new issues about the macros is something that I had not foreseen, and so we will look at that, and hopefully you can shed more light on that. So one scaling down that I have, that I'm proposing that we do is the number of warnings. We can be selective about the warnings, and maybe we can use those which warnings that we select for you to analyze, and further experiment with CBMC. Maybe that will help or not help. Okay. Now with CBMC, what I had asked you to do was to at least pick a couple of them that occur within some loop. And I understand that the kind of loops, there are not very many nested loops, but there are kind of global loops, and some of those warnings can occur inside the loop. So you will have to look at the loop, and then get some kind of an estimate about the worst case number of times that some of those loops potentially execute. And what I want you to do is for those selected set of warnings within CBMC, to explore up to that a number of unwindings. Okay. Now let's see. So how many unwindings you can do in CBMC, whether you can do or at all or not, is something that we will we will discuss. Okay. Yeah. So here, in order to assist, there are two things that I'm suggesting, that to scale down the kind of warnings that you do, and also jointly analyze, and we can help you there in terms of the number of unwindings up to which you need to explore CBMC to check those warnings. Okay. The second, in C, I want you to do two things. Once again, it depends on how well CBMC, how many instruction execution. See, I consider the emulator execution in terms of number of instructions that you execute. Okay, that itself may involve certain number of unwindings. I presume that the outermost loop in your emulator will correspond to execution of one instruction. That itself may involve other loops that I have, will investigate. So I'm going to measure the CBMC length in terms of the number of instructions, number of CBMC steps that you will have to do in order to execute a single instruction. Okay, that I presume will be one unwinding of the outermost loop of the emulator. Okay, so with that assumption, the verification of the overall verification of the second thing, okay, C, what am I saying? So the task C will involve verifying select set of instructions. Here, I'm willing to even scale it down. You can verify one arithmetic instruction or one load store and one jump. You can pick the simplest one. Using, and what you need to do there is, let me show you. So, okay, which diagram that I wanted to show? All of them are named the same. Yeah. So this is what I want you to implement, okay, as part of it. This will involve only one. You see, the step here is pretty much you define what if you were to execute a single instruction, say an arithmetic instruction, on the externally programmed visible registers, what it takes to, when you execute it, what is the expected effect on the thing. For example, if you did an arithmetic instruction, add instruction, it would add two registers, say, and the result would be written into the destination register, and the PC will be incremented by 1. And maybe if there is overflow, underflow in during that execution, some condition code bits will be set. And all that will be described as a pre and post on those expected state. Now, what you will have to do is to check exactly that if you initialize the memory with that instruction pointing to the current PC, after you execute that, the actual concrete state that you get, when you project that onto the relevant components of your thing, will have the values as you specify in the upper loop. So this one will involve only one step execution of your emulator loop. So I presume the CBMC, you should be able to run it to execute one instruction. If you're having technical difficulty in running inside CBMC, the outermost loop, even for one iteration of that loop, then we can, we can see. We'll see, how to, solve that technical issue. And if those macros or whatever that you mentioned, was that Siddhant who mentioned, Chandradeep, I don't know who, we can look into that. Okay, so let's first, I will describe what I want, and then we can get into all the technical issues that you're facing. Now, the second part, okay, now here I've exactly told you what, okay, the general scheme is exactly doing what I just now, showed you, implementing that, what I call as the commute, the commute diagram, okay? So which essentially it involves making certain, it essentially involves initializing the memory to the instruction that you want to verify, and then execute the emulator step. One in emulator by one step to execute that instruction, and then check an assertion, which verify an assertion which checks that after execution all the relevant components like the contents of the registers and PC are updated as you expect. Okay, so that is what I want you to do there. Now, in your the other part, C will want, as I said, 1 and 2, you will need to verify a couple of programs that when you execute a couple of programs, that we will give you one a loop-free program and one a program with a loop. Okay, I've already defined what the program, the loop-free program that I want you to check. I will define a loop-free program also. A program with loop, a simple loop, and then you want to check. What does that mean? Okay, checking it is what I have described here. First, you can write your program in C. Okay, whatever program. For example, if you take the first program that you wanted to check is a program that swaps the contents of two locations, X and Y, stored in memory, and stores into another location, Z, in the memory, a maximum of X plus 1 and Y plus 1. Okay, that's what, it swaps and then stores the maximum of the two locations. Now, first, suppose you write your program in C. Okay, how would you verify such a program with pre and post is what you will have to work out. Okay, so you will have a precondition and you will have a post condition. Okay, and then you suppose you hand translated your C program into a corresponding 8086 assembly code. Okay, you may introduce intermediate assertions at critical locations. So that is more relevant for your loop program. So because a loop program you can verify only by proposing some loop invariants. A loop-free program also you can introduce assertions, intermediate assertions at critical locations, which are correspond to some blocks. Okay, for example, in this program, you will have an if then else to compute your max. Okay, maybe you could have some intermediate assertions at different locations to help you incrementally verify the program. But so suppose you hand translated your C program into a corresponding assembly program in such a way that you maintain those location points at which you associate assertions. Okay, maintain correspondence between the C program and the point in your assembly program at which corresponds to that that location. Since you are hand translating that C program into your assembly program, you should be able to do that. Okay, and you expect those assertions to hold good at those locations at the PC locations in your assembly program. Then what you need to do is to devise a suitable method to verify that assembly program when you execute that in your emulator. Okay, and how do you do that? So the idea is to convert the verification of the assembly program into one of verifying all the assertions for the program that you have introduced on a trace of the emulator. And what is that? What does that trace correspond to? It corresponds to execution of the hand translated program when it is loaded into memory. Okay. After you load it into memory, and then you execute the emulator. Okay. So, and when you do that, then you will have to check all the assertions that you would have introduced into that assembly program. And how would you do that? So that would be, each time you execute one instruction in an assembly program, you are updating the C. So you will associate those assertions at that point, presumably at the outermost loop in your emulator, and those assertions will be if I'm at a particular PC location, then certain condition will have to hold good, and that's how that you will verify. So if you only have one pre and one post, pre associated with the entry point of your program, and a post associated with the when you have executed the last instructions of your assembly program, you just have to make your pre as an assumption, okay, on the appropriate contents of your registers or your memory locations. And then the assertion that you will be checking will be when your PC gets set to the location at which the last content of your program is stored. When you execute, when you get to the exit point of the program, which presumably will be PC post 1, at that point, then you will expect the post assertion, which will be some constraints on your output on the contents of your certain locations, and that's what you will verify. Now, for a program with loop, what you will have to do is you will have to implement the same thing. How would you verifying the C program? You would be splitting them. If you were to be verifying a C program with CBMC with a loop, if you want to do it in a complete fashion, if you want to do bounded model checking, you would be unwinding the loops. Okay, that would not be a complete verification. If you did a complete verification, how you would do? You would decompose the verification into 3 parts. One is, you will introduce an assertion at the head of the loop. So you will have one part which verifies if you started with the pre for the entire program and executed the code preceding the head up to the point you encounter to the head of the loop. That assertion, which is really a loop invariant assertion, holds good. Then you will have one inductiveness check. That is, if you assume that the invariant hold good and then executed the body of the loop, then that assertion will be preserved. And then you will have when you exit the loop, okay, that you would do. So those 3 verification conditions will have to be checked, okay, by in the emulator as it executes the program after it is loaded into the thing. Okay, so that's what I want you to to do. Okay, now that is pretty much what I want you to do. At least modulo the kind of technical issues that you're having, and how whether which ones of them we could solve, and if some of them are going to be showstoppers such that you will not be you will not be able to complete any of these tasks, I'll take responsibility, for that. Hopefully, those issues will be, we could solve it together, enough so that you will be able to at least execute some of each of these tasks to our mutual satisfaction. Okay, so with that, I will end my what I have to say and take questions with what I have so far, and then we will look into all the technical issues that you have. Any questions? Well, no questions. Okay, so then I guess there's no issues you have. Hello, are you guys there?
Yes.
I think we have to rewatch the live stream, and like some of the parts went over my head. So I think it's the same for most of us.
So I guess few of you guys are having some specific technical issues, so maybe we can talk about that.
Okay. So and then I didn't quite understand your comment. You didn't understand. I was too sketchy, and you wanted to. I went too fast. Is that what you're saying?
We can rewatch and then mail you if we have any problems.
No, but that may not that well. I mean, you guys rewatch and then you never ask questions. Okay. So, until we describe, the only other thing I can do is I'll have to lay out the entire thing, work out an example, lay out the whole thing, how you do it, and you guys will only be able to implement, even if that is the case. Okay, but anyway, I can provide more illustration as to what it means that you will have to do. So, which means pretty much we will be implementing some part of it. That's okay. That's okay. If it is generally very difficult for all of you, then the only thing that we can do is to solve the technical issues that are, if they're real technical issues that are showstoppers, then I don't think, that we'll have to figure that thing out. Let's see if that is the case. Now, regarding how you will solve some of these things, we can certainly provide help in that. And then even if you're not able to completely implement it, there is some aspect where you will do some, pencil and paper, and then you will, and you will, even if you're not able to do it for all the instructions that we want you to do in the case of C1, and for C2, if you're not able to do loop, I mean, let's see how far you will progress. The idea is that you will hopefully learn something out of doing this thing, even if you haven't been able to completely execute. Give it an honest attempt, and we will provide all the help that we can. Let's take that question as to how what I have, giving more support and more information, and getting things clarified as to how you will solve based on what I have described separately. So let's take this issue from what Siddhant described. It seemed like there is some issue where you can't execute anything at all in CBMC or ever, is the kind of impression that I got. Okay, so that is a little bit scary in the way that you put it. And let's now take that issue. So what you're saying is pretty much you can't run ever CBMC on this code. Is that your point? There are some issues that makes it hard to run CBMC or ever on the code. Is that your claim? I don't know. I mean, you guys don't answer.
Yes, I mean, like, I feel
So
like the
you just
code is
are
written in a way.
silent. What do I expect, huh? Yeah.
I feel like the code is written in a way. So there are like obfuscated C code contests and like C poem contests. And this code is written like that. There are no comments. There are so many magic constants.
Yeah. So,
and
so what you're saying is that it will be hard to analyze, is it? Or are you saying that you can't run EVA at all?
Not only that, as I said, like when we expand the macros, the main function becomes like the only function in the code, and it's like 1,500 lines. And so CVMC, even with like 4 unwindings, it becomes impossible to generate anything. Just crashes.
So you the thing is that you will have to check. Okay, without the macros. Okay, there is something. Okay, Diganta, do you have anything to comment?
Yeah.
Or do we take a
So,
look at that between us before we can come back to them? Because I had the impression that you were able to generate certain number of warnings, okay, with EVA. Okay, the last time when I checked, when you what the status was, I thought the response was that you were able to generate some 250 violations, okay, and then this issue was not brought up last week, but now. Is that an issue only with EVA? I mean, with
yes, EVA doesn't have any problem.
Huh?
EVA is running well, I think. Nobody is reporting any issues with EVA. It's just CBMC which is causing an issue.
So it's CBMC when you unwind. Okay, so that's a little bit more hopeful. Because maybe, why do you need to expand those, without expanding those macros?
No, so like one instruction is one macro line, but when we expand but that macro contains like three assignments and additions and casts and all that, and EVA will generally ask to create assertions between the assignments. So like there might be an assignment from an unsigned to an signed, and that will all happen inside the macro. So we need to expand to add.
So let's suppose that you ignore those assertions that are inside.
Then the code basically becomes empty, because the code is really short, but when you expand, it becomes extremely large.
No, but you have to expand all the macros, or only macros corresponding to certain.
Can I say something here?
Yeah, please.
So I think, this issue is there in the sense that the code is mostly written in terms of these macros that will have to be expanded and so on. But I think that shouldn't, at least from what I understand, that shouldn't be an issue for CBMC and all, but that will definitely be an issue for manually understanding what's going on and so on, right?
No, so when you add more code, CBMC generates more steps. So as I said, like with 4 unwindings, SSL generation takes 16 GB RAM. That's because it's 1500 lines, no?
Yeah, so I think
1500 lines of code of C, typically CBMC should be able to handle. Okay.
No, but there's one function, not like separate functions. If it was like small functions, then we could have isolated them and analyzed them individually.
So how many functions are there? So maybe that we should.
I think like 2 or 3. There is the main function, and there are some 2 or 3 auxiliary functions, I think, and they are like really short, 3-4 lines.
So I think there is a few things that we can try, sir. One of them is that maybe we can limit the internal RAM size in the emulator. If that will help at all. So is the RAM that when you're saying the CVMC is running out of 16 GB memory in your system, is that in the SSL generation step, or is that in the SMT solving step? Can you?
So for 4 unwindings, it's SSL generation step, and for 10 unwindings, it doesn't even it keeps running forever. So in the loop unwinding stage.
So even with 4 unwinding, it doesn't get to the point where it's calling an SMT solver at all. Is that the situation?
Yes, after
CVMC has this. CVMC has a message that it says where it will say that, okay, now I'm calling SMT solver with such and such trick. So do you get to that point with code unwindings, or even that is not happening with code unwindings?
Yes, I think that happens after the SSA generation.
Yeah. Okay, so even with code unwindings, it is not even being able to call an SMT solver is what happens, right?
I think we should check because I'm not sure.
Yeah.
Okay.
I think it doesn't call the SMT solver.
So even it gets stuck even in the unwinding stage.
No, that's
Yeah.
for
The SSA generation.
That
No,
is
the SSA generation. There's no particular step of SSA generation. When you do
So the thing is,
unwinding it first, it's converts into goto. Okay, one of the things that you can do is you can see if it even dumps a goto function. Okay, after that there is it does unwinding. Okay, it's only after unwinding does it convert it into after during the step of unwinding. So for each step of unwinding, okay, after it unwinds only the go-to functions. Okay, after it unwinds, it converts it into SSE. Okay, and then it generates. So without actually does show go-to functions work. Okay, that is something that I would do. Next,
so
does do one unwinding and do show VCC. Will that work? Okay, if that means that SSA generation has been successful for one unwinding. Okay, and that is something that we could do. So we can actually do right now here. Okay, and if you want to do a demo.
Yeah, like I think it is a good idea to try right away. I'm actually so can you tell me what flags you used, what checks that you were doing with this, so I can try on mine.
you can get my repo. It has some assertions added now.
Shall I make you a co-host? Diganta?
No, sir, I won't be able to share screen because I'm on mobile. But Chandradeep, if you can share screen, if you have something on your screen.
Then 1 minute. I'm on iPad. 1 minute. I will turn on the laptop.
Yeah. So is this Siddhant or Chandradeep? Which one?
Chandradeep.
Chandradeep, I'll make you co-host, and you could.
Oh, I will rejoin. 1 moment.
Okay, so Dhruv says the problem is mostly with CBMC. So with CBMC, I think we should be able to solve it. We know we have a lot of resources, at least familiar. I'm more familiar with CBMC, and also we have a lot of support with CBMC. Okay, so we can get that thing done. Okay, let's see where we'll have to see where the problem is. Okay. So, but even with all the macros expanded, if the number of lines of code is only 1,500, okay,
yeah,
then I don't think CBMC should have a problem, okay, is what I believe. But let's see where the problem is, okay.
Yeah, like 1,500 lines as far as C code is concerned is still not too much.
Yeah, I should not, unless there is some. No, I mean, it pretty much supports all ANSI C features, okay? Unless it is using some weird part of pointers, dynamic memory allocation, and
No, I don't. Like, at least memory and pointers wise, it's not using anything.
Yeah, I think what we should do is the two of us, Diganta and me, we should run the thing exactly after.
Yeah, that's why I want to know what exact flags he's using, so I can also I'll also run it immediately, or at least where the assertion he has put in.
Correct. Yeah.
So so that we can try it out on our end. So Chandra, if you can share screen and show us that.
Yes, one moment. Oh, and one more thing is before the SSA generation, it tells how many steps need to be executed or something like that. So I think for 4 unwindings, it's like 16,000 steps or something like that.
So what do you mean by steps?
One moment, I'll show you.
Yeah, because there's no notion of formal notion of steps in CBMC. Okay, so I don't know what you're referring to there. So maybe we can understand that better. But this is certainly that I would do. Okay, so let's see. What you do. You will take one step at a time. Yeah. We started at, yeah, we've already gone 50 minutes. So well, let's agree to stay for half an hour, to understand what the situation is. Okay, and then because it will be getting late for you guys, no? So it's past dinner time.
Can you make the other me co-host?
I thought I made you. You're already.
No, so there is another Chandradeep who needs to be made co-host, I think, sir. So that is the one that he has from like the laptop, I think.
Chandradeep is already a co-host. Who else do you want?
Another Chandradeep.
Oh, there are two
Chandradeep.
Yeah. I see. Okay.
So I'm just running it with some generic like overflow checking assertions, and it has generated some 1100 PCCs and it's converting to SSA right now. And yeah, it's definitely using up a lot of memory.
It is using a lot of
memory. I think it's using 77, like 80% of my system memory already. So that is around 24 GB of RAM.
Hasn't crashed yet. I mean, is it going still?
Yeah, I mean, I think it will go for like some time more on my system, but like it will crash. I think I'll just let it crash.
So, but this is for how many unwindings you're doing?
This is 4 unwinding. Yeah, so I think we'll have to figure something out. But yeah, Chandra, they still show what is it that you exactly ran.
Yeah, I think then there's at least there's hope for the other two, because the verification of instruction at a time, it requires only one unwinding, I think. So yeah. I mean, when we say unwinding of the topmost loop is what I'm assuming that we mean, right? When you say 4 unwindings, yeah?
Yeah, no, so if we only specify...
The other thing that we can do is, I don't know, I haven't looked at all the loops. We'll have to seriously look at all the loops in the emulator code, and we may not need all the loops all the time, okay? The topmost loop, certainly we will need, okay? So instead, if you do 4 unwinding, it'll unnecessarily unwind all the loops that may not be needed all the time, okay? So we can selectively unwind those loops that we need, depending upon what which assertion that you're verifying, and we can do that kind of a rough analysis, and then selectively unwind some of the loops, okay, that we think are absolutely necessary, okay, and then set all the other things for 0 unwinding, and if we are not then we'll, something like that is also can be will need to be tried. Yeah. So you can use different unwindings for different loops. And then the other thing is the RAM size, okay? Is it overwhelming some of the things there?
Yeah, I killed it after it has like used up all of my system memory and was going into swap. So I killed it on my end. Yeah, so this was in terms of the property that I was checking, I just added the unsigned overflow check option to CVMC. So it was probably checking a lot of properties because unsigned overflow could potentially happen in a lot of cases. But yeah, this matches with what Chandradeep was describing, and he was only trying it for one assertion. So yeah, so could you show what assertion?
This code, for example, has 10 assertions. So there should be, so like these. So these are for like, what are they called? Shift operators, right operand being less than or equal to 0 and 32. So there are 10 assertions here for 5 shift operators. And also this is the stuff I was talking about. So the macro expansion does this stuff like unsigned int and then 8 times int of something. And then this is a different type and this is a different type. But at least I have some of the comments preserved. So it's like still readable, but not very like understandable. Like I can see the Eva code and I can see this code and I can understand what like the two code that they're similar. If the macro was unexpanded, there was no way to understand. But with the expanded one, I can only understand the two codes are similar, but I don't understand what any of the code is doing. Okay, so let me just run this in CVMC.
That is.
I mean, you will just see the thing you're seeing on your memory thing. So Control R, CVMC, Dino graphics, 86 tiny, unwind 4. I think unwind 3 works. Yes, unwind 3 works. And how many VCCs generated? Generated 0 VCCs. Why? Oh, this is the wrong file. No, this is the right file.
Is this with the macro expanded?
Yes, this is macro expanded.
But what does it mean to say there's 0 VCCs generated?
Yeah, I think something has gone wrong. Just checking that, I think.
Huh? Maybe you have.
Okay, let me just remove the. Let me use a flag. What is undefined? Undefined shift.
No. Don't unwind and see. Don't. Okay. So don't let's see. So you have to, without unwinding, don't choose a particular unwinding with.
No, then it runs forever.
No, there is something where you could just choose the option and. What do you mean it runs forever? See, because if you don't
keeps unwinding and keeps unwinding. So since like CVMC can only detect the unwinding that for like simple loops, but not for these loops. So we have to set like one.
How many loops are there? Can you check how many loops? I think there is a way to
31.
Enumerate all the loops.
Actually, not 31. I guess there are some comments. 12 loops.
12 loops.
And actually, one and 2, 3. I think probably 8 loops. And some of them are in 8 loops.
Only 8 loops. Okay, good.
Yes.
So are all the loops, can you look at each of the loops? Okay.
I think some of them are in this, the 2-3 line functions that I told you about. So this one, the set flags function, the make flags function, these have loops. And other than that, everything is in the main loop. So the main loop is a switch case and with like
Yeah, the main loop is a big switch case because that corresponds to the all the other loops. Let's suppose that I think what might be happening is that see because there is such a big switch case, okay, that yeah, so I can see. So because with each unwinding you get these big switch case, correct? Yeah.
oh yes, this is the thing I was talking about. So size of program expression 305 steps.
That may be the I think steps in terms of the number of go-to steps, I think.
So, yes, so with unwind 4 it becomes like, oh, so unwind 3 it has 300 steps, and now with unwind 4 it's like 35,000 steps.
So
This
there's
is
an
some
inflection
exponential,
point there.
and this will just take memory until it gets this. And yes, that like, so some of the loops, so and even then analyzing these loops are really hard. Like there are like 4 layers of brackets. Who knows what this means?
No, when I say analyze loops, I don't mean, I mean you have to analyze the assertion that is generated. Okay.
Oh.
But I mean, I do agree with you. So in order to see if it has really failed or not, you will have to do correct. So by the way, all the other loops, there are all all the smaller loops have a fixed number of iterations, correct?
These have fixed number of iterations because they are just like, I think, the number of flags. But the other ones, I think, so.
When you say these, I mean, you said there are 8 loops or so, right?
Yes, so the ones in the make flags and set flags, these are fixed number of iterations. But there are other loops which ran forever, I remember. This is inside no graphics. Let me just check. This is
Suppose
fixed.
you turn other than the main loop.
So there are these loops which use like internal variables and like temporary variables, which obviously we need to track the whole thing to understand what is happening here. So there is this scratch variable that they assign to, and then they decrement this. So this could potentially have like 4 million or something unwindings. But if we could track this and understand what is happening.
That is something that we need to look into. So what I would do, go to that for loop. Yeah.
This.
How do you read this for loop? Okay, so you start.
No idea.
No. This is which is the index here. Okay, index is scratch uint.
Yes. So.
And based on C syntax, how would you read this? So this is.
So scratch uint is assigned a value based on if this boolean, if this thing is 0 or not. If it is 0, then we assign 1 to this. So that runs for only 1 iteration. And
yeah, this is only 1 bit, no? This is only 1 bit. So you're assigning.
No. If this is true, then we are assigning whatever value is inside this array.
No. Wait a minute. Inside that array, but how the first element of that array, but what is the width of this? Which is 16-bit width, or is it just reg 16 is a register array, or reg 16 is just a single register whose single bit? That's not the thing. So it is a 16-bit value. Huh?
Yeah, it is 16-bit value.
Yes, it's a 16-bit, but let me just go to the definition.
So I think that this part of the code, there are certain instructions in the instruction. Yeah, it is an unsigned short, so it's 16-bit, but there is certain instruction in the instruction sets where you can basically say that execute the following instruction for like however many times as is the number specified in this particular register. So I think that is what's being handled over here in this loop. So it can actually, like, in the worst possible situation, run 2 to the 16 times this particular loop.
See, I think these may not be needed. See, if we see what that we want, all simple instructions. Okay, so here it may be, there may be some call or some repeat instructions or something. I don't know. I mean, 8086 may have
Let
some
me find the for loop again.
what?
Let me find the for loop again.
Hmm.
So it's this instruction: move as X, STOS X, and LODS X. These three instructions.
It's a move instruction.
Yes, something related to move or store or load. So, okay, let me just open that manual thing that Diganta posted. Yes, right. Tutorials. Exams. This. These, right? Move SB, move SW. This.
See, this execution, this instruction, why does it even require a loop? Because it's copying byte DSI to ESDI, or it is copying a whole bunch of bytes, is it?
Yeah, I think that is what is like. If you go down a little.
There is a repeat. Okay, there is a repeat here. What is REP? Huh?
Yeah, I think REP is
repeats itself.
Yeah. So you see, I think if you could, one way is, since we are, these kinds of, we could slice off certain instructions. Okay, so you could just set them, say we are not concerned with that part of the code that implements these big repeat instructions. I mean, I had worry, okay, that because it's a complex instruction set, okay, the 8086, some of these repeat call, function call, function routine, those kinds of things which may require a lot of data dependent, okay, loops. So you may need to cleverly slice that part, okay, or you could just make those for loops with zero unwinding, okay.
Or I think one unwinding, right?
Well, you could do, I mean, you could do one unwinding, but I mean, let's see. What I'm saying is, if indeed, even 3-4 unwindings of that loop is big, okay.
So
and with
how
this,
about replacing that code with this no code? So this is probably no operation, and we can just
that can
replace
also
that.
we are mucking around with the code. Okay, first, what happens if you just did, just to see where the explosion of the number of steps, okay, in your go-to after unwinding, the number of steps is exploding from 350 to some 35,000 or something like that, 100 times, right? 100 times it is getting. So if you did that, the unwinding, set the unwinding of that to 1 or something like that, okay?
Try that.
I mean, the only advantage is that I'm not mucking with the code, okay? I'm only restricting my analysis to 1 unwinding of that, which means that will limit myself to exploring execution of those instructions to limited data, okay? yeah, then then we get an idea of if that scale. There may be other loops of this kind. No? You'll have to identify.
I think there was one more.
There was only one
The
loop.
very next instruction had one.
Okay.
Yes.
Do a show loop, then you can probably specify an unwind set.
No, sure.
So Chandradeep, I should appreciate your effort here. Okay, so you have really done some analysis on your own by your own initiative. So I appreciate that.
No, I think these two. Main two. No, yes, this is the one. So should just set these to 0 unwinding, right?
Yeah, I mean, you could do 0 unwinding to begin with, and then increase it to 1 unwinding if you want. 0 unwinding pretty much means that you're not verifying those instructions at all. Okay, that's okay. That's okay too. So to begin with, if that will help, or where the complexity is coming from.
And I think there is one more thing that we need to do. So skip loops, partial loops.
And why did you save this command line?
It will be in my history. Probably still missing some.
Oh, you mean to say there are some other loops still?
You missed main 3, I think. What is main 3?
Let me see first.
I think main 3 is the main loop.
So first is this one, 521. Oh, 521 is, sorry, this one is just the file opening thing. So this should be
okay. Yeah, so main 3 should be 4 and main 0 should be like, okay, yeah, both of them, I think.
Main 0, I guess 4 is 5. And we should add this main.3. This should be how much? 4.
Yeah, I think it should be 4.
It should work. Still, I think that's right. Still, there is 42,000 steps.
Yeah.
So I think 42,000 is fine because I like set some of these to 10. So like the ones where the number of iterations was fixed, I set them to 10. But let's see if it does generate. Probably not.
Yeah, I think this will not work. This is already hitting swap, right? So can you try this, like remove all but one assertions and then try this reachability slice feature that CBMC has? So do you think that will help?
So now here, are you trying all assertions or just one?
No, just
assertion?
like 10.
Ah.
So maybe just comment out everything other than just one assertion.
Okay.
In the, we can save like a different version if you.
Oh, but that'll take a long time, no?
No, if it's just 10, then you can just quickly comment things out. If it's more than 10, like yeah.
But why, yeah, so you're putting assert there. So, but does it, that this is automatically inserted, no?
No, I wrote this.
Oh, so
you
not...
wrote this from Eva, right? Like you translated
Yes,
the Eva's assertion.
This is copied from Eva, but I just like see, like Eva was writing it in its own syntax.
So why didn't you try CBMC's own assertion generation feature?
I think that will generate a lot of assertions, and we were like, I think we had originally like the workflow was originally set as to like use Eva to eliminate a lot of.
No, I understand, but you can generate them.
Oh, right. Some of these have one moment.
Yeah, I mean, reducing the number of assertions, I don't know if that will reduce the thing. You were saying that what option? Reachability option, is it that I'm not familiar with?
Yeah, this reachability slice option that it has. I think like from reading the like description of it, I think it will work best if we have just one assertion. That is why I want to get rid of all the others. No, just add the reachability slice before you run it. Add this reachability slice option. This one.
Yes.
Yeah, there is another one. I think like try these options basically. I think the AFP reachability slice isn't what we want to do. I think, but the reachability slice and reachability slice AFP is something that we can try.
So just add them directly. No.
Just add the reachability slice. I think. Yeah.
Okay. So this just do reachability the slice.
No, I think it'll still not work.
So it has removed about 5,000 assignments, it says.
But I mean, it is still.
So unwinding itself doesn't take much time. So converting it to SSA takes a lot of time.
Unwinding starts taking time when you do like unwind 10. Then then even unwinding doesn't happen. So if I do main 310 here, this it will like run forever.
Yeah, I think then in that case, we'll have to do what you said. If we are not interested in certain instructions, if you
So
could,
we kind of already did that now with zero unwindings.
yeah, but here you're not using zero unwinding, have you?
Yes,
Are
I
you?
used zero unwindings. So this was the command. So it is main 10 main 20. Oh, I should have.
Hmm.
So
Yeah, I think this will just eliminate those inner loops, right?
So are there any nesting of these loops?
yes, so this is the list.
So I think
Okay.
sorry.
So in the interest of time, this is something that we need to take offline. What's the time now?
Yeah, sure.
I think this loop unwind, I mean, the loop analysis I had already proposed, okay, as part of the strategy in my detailed task thing, which has to be done. I mean, I had proposed it in the context of analyzing the warnings, especially those for those warnings that occur inside the loop. But for unwinding, to control the unwinding, that we'll have to do. Now, if we are interested only in checking the emulator code for a restricted set of instructions, say, then some of those cases can be completely nullified, right? Like what Sandeep was, Chandradeep was, suggesting. Say we're not interested in any of the complicated ones, or if we are only interested in some instructions where we could write some meaningful programs, a small set, and then see. I mean, yeah. So in order to get to the
Actually,
point,
one error with even that. So because it's like 8086 tiny, so some of the instructions are like bunched together. So if a flag is 0, then it means one instruction, and if a flag is 1, then it means other instruction. And it's so like so it's not like there are 200 instructions and the switch case has 200 parts. So it like merges some instructions into one instruction.
you're saying you can't identify these instructions separately?
No, we might be able to, but not guaranteed. So we might want one instruction but not the other. But if we want to comment out and remove it, so we will.
You may not get the other instruction, is what you're saying. Certainly certainly the complex instructions, if we can go through the 8086, which will require retain only those things that can be executed without any repeats and without any dependency on repeatedly doing things, okay, which all require only a finite number of we'll have to do something like that to get some thing out of it. Okay, I see. I understand the issue with the CBMC. So we'll have to figure out, how to do that. Let's. Okay, so Diganta, we have to take this offline, okay, and then maybe involve Chandradeep, okay, because he has made the most progress in understanding what the issue is, okay.
Right. Yeah.
So sometime, early this, night, evening or night for me, and night for me, and then, as late as you want, so that it is morning for you, so which is convenient. And if Chandradeep wants to get, or you can talk to Chandradeep separately, kind of pick his brain a little bit and try to understand some of these issues, how to cut it down, okay? And then we can take it further between the two of us.
Yeah, sure, sir. I'll do that.
Yeah, so do that maybe with Chandradeep if he has time, before my evening, and I will suggest a night time, my night time for you, okay, which is tomorrow morning. And it's too late. If it's too late for you today to continue the session with Chandradeep, you will have to do it sometime tomorrow early morning, so that I can meet tomorrow mid-morning or something like that. Yeah?
Yeah.
This is on India time.
Yeah. Okay, sure.
Or we do one session early in the morning, your time, and we will try to go through the code and then have a brainstorming session between us, and then you follow it up with Chandradeep. Yeah, that may be better.
Yeah, I think that is probably better. Unless so, Chandra, do you have any ideas as to what we can do? So
if we write a different emulator where there are more functions that we can isolate.
How will that help? I mean, when
So
you say
we can analyze one function at a time instead of the whole thing at once.
Yeah, but the function is not the problem, nah. You mean one function means one instruction, you mean?
Yes, I guess the switch case would be all functions instead of just doing everything in that one line.
No, but then how do you write one instruction at a time? That means that you will make all the others know up. No?
Yes, so maybe an array of function pointers, and then the function pointers will be indexed by the instruction number, and then the for loop actually just calls the function pointers with the functions with the appropriate data, and then we can check the memory before and after executing a function, preconditions and post conditions.
No, but you will be still be using.
I was joking.
No.
Diganta suggested, what do you want to do? I was suggesting that let's write a different.
No, but I would, because the idea is to verify the code. So I would slice the code, any techniques to slice the code by commenting out parts of the code in an intelligent way is the approach that I would suggest.
For that, we need to read the code, but the code is I think at least it's unreadable.
But even for identifying those parts of the code that executing a particular instruction depends on, because you can take.
These are the things that are unreadable, I think.
Yeah, but those macros are unreadable, is what you're saying.
Yes.
Yeah, but those macros might be needed if we know what instructions that those macros are needed for.
I think all of them. Somehow, these.
Why do you say they're needed for all of them?
So, these macros, some basic stuff, they simplify loading and storing, and looking up data by this stuff, looking up the instruction and everything. They cram it into one line of code. So let me just show you an instruction with the macros. So suppose this one, let's say. So this one. This is add or add with carry, subtract with borrow, and sub, like all of these instructions combined. So it takes some address, and then this is a macro, and this is a macro, and this is a macro.
Hmm.
And then when we expand it, it would look like, let me show that too. When we expand it, it will be so this one, this one. No, this one is actually short. This one is large. Yes, so there is this macro, and there is this in function, I think, and this becomes like this. So like all instructions need these sorts of like pointer manipulations, and these are like, I think, reinterpretation casts. And so like they take one type, and then instead of casting it directly so that C can like change the data, it like takes the address and then changes the type of the address, and then like that looks at the data of the address as a different type.
Hmm.
So these are usually really common things. So they have this thing ADC. So this ADC expands to this, but it was like one line here.
This is inside the macro, correct?
So this is the
the
original code. In this original code, there was opcode 2 ADC. This was just one line of code. But when we expand the macro to see the actual code, it becomes this.
So
This
there is,
has no
okay,
macros.
that itself has multiple cases, okay, and there is a case explosion there when you explode.
Yes, there are a bunch of like these, what are they called? Ternary operators, question mark, assignment. And Eva will often want like to put an assignment before put an assertion before the ternary operator is executed, or like midway. So we would need to like change this as well. But this change is actually understandable. But the first change is like we can like write an assertion by replacing this, because we don't even know what is happening here.
Because that is unexpanded, no?
So like what Eva often wants is basically this. So this one says, so there were like the ternary operators. So that Eva wanted the ternary operator change, so it becomes if I underscore w, and then there is there were like 3 assignments bunched in one line. So now there is one line, and then there is sequencing, and then there are asserts, and then there is like more sequencing and more asserts, and there are like Eva introduces some temporary variables, and then does assignments on temporary variables. But this stuff is like done in like 1 line or 2 lines, even like after expanding the macro. So this thing. So yeah, this is after expanding the macro. And what Eva does is it basically changes all of this 1 liner to this thing, which is like 100 lines on its own. So there are comments.
Yeah, but you're not using the ever generated code, no?
Yes, this is the Eva generated code.
But what, are you using the ever generated code to do CBMC analysis?
Yes, because otherwise we so in case 0, let me see.
So ever, you're saying changes the code.
So yes, but like we need that. So like
Eva is only expanding it.
Eva?
It's not doing much. So like it's changing the ternary operator to if else, and it changed like if there is like one assignment and then A equals B equals C, then it puts the B equals C on top and then A equals B later. So like we can put assertions between them.
Yeah, this is some of this complexity is also coming due to because we want to have the warnings actually generated by Eva, right?
So for example, this is the part.
Yeah, so that part. That's why I was also thinking that whether we could simplify that task by yeah, see, CBMC can be made to generate its own assertion for doing all these overflow checking and so on. Okay, on a fully expanded code. Now, then of course, it'll be hard for you to put corresponding assertions. Okay, which of these warnings correspond to those assertions? Okay, so you have not done that, right? So you've not used CBMC's assertion generation feature, have you?
No. But
On
won't
the
it generate like thousands of assertions, as Diganta was saying?
yeah, it would. That is correct. But so that's also an issue. So because it's already now reduced, Eva's assertion is reduced, right? Mm. Okay, so I think this one now coming to think of it, the task C is probably easier than task B. Okay, because this thing is because the source of these assertions are somewhat mysterious, whereas in task C you can control exactly. Okay, so for example, verifying a single instruction whether it is implemented thing, because that involves just that one instruction. It only requires one unwinding. Okay. So in that sense, I'm more hopeful for task C1. Task C2, of course, may involve multiple instructions. Okay, and that will involve multiple unwinding. But then you know exactly what instructions are involved in your program. So then you might be able to do some things to turn off some of these cases. So I'm more hopeful for tasks C, which I'm sure you guys have questions about the methodology. That we will then I'll clarify. Now I understand where the complexity of task B, which is the assertions generated, checking the assertions generated by Eva with CBMC is coming from, because it is the assertions are spread all over the place, and you will have to figuring out how much unwinding etc. you need to do and how to slice them is requires a lot of insight into the code. Okay, so scoping that task down is something that we will Digant and I will discuss and do it. Now I know that I went too fast on explaining to you what is involved in verifying the thing. So maybe that I will put out an example, okay, so that you can do another instruction with it. So that should clarify, and I will explain it tomorrow after discussing with Diganta. So let's end it there, yeah, because it's getting late. Yeah, thank you. Yeah, I mean, if Diganta can hang on, the rest of you can
Yeah, sure.
drop off.
Okay. Bye.
Yeah,
Thanks.
thank you.
I think it's Chandradeep's other account that is still here, right?
Yeah, his one account got disconnected, but the other account is still there. Is he there on the floor?
I'll ask him on WhatsApp.
Chandradeep, are you there? I don't think he's there.
Wow.
I think pretty much we'll have to do something on our own to get to regain confidence. Okay, so that we can instruct them.
Yeah. So I think we have to some. So at least my my understanding of what's happening is this. So whenever we're doing like a two unwindings, it's basically trying to check for all like possible like a sequence of instruction executions that could have lead up to this assertion being violated, right?
Yes.
So instruction right before the last unwinding could be anything. So in that unwinding, we are actually having to like check all the cases in the switch essentially. Like include all the cases in a switch in that step.
Yeah. So each unwinding introduces these nested cases. Okay.
Yeah, and that is going to blow up.
Yeah. So if you're only interested in a small subset of instructions, say only a handful, 6 to 10 instructions that will allow us, then I was hoping that we could turn off lots of these.
Yeah.
These
so
things.
I think we can definitely do that, but like Sandeep was saying, that there might be a problem in how do we actually like turn off most of these cases. Like he said that identifying those cases might be difficult and so on.
No, but on the cases, as long if the cases are corresponding to instructions, particular instructions, then we can always turn it off. Oh.
Yeah, but there is the one-to-one correspondence is not exactly there. It's like some cases handle multiple instructions because that led to a more complex.
Yeah, we can go, no, but if the macros are expanded, if you go into those things, then the cases.
Yeah, we can dive in and really get our hands dirty into that.
Yes.
But yeah, it's going to be somewhat messy. I was thinking of another approach. I don't know if it'll be more or less easy to do that, but just to add beginning of the loop, like say we are only interested in add and subtract, let's say for example, then we add and assume in the beginning saying that okay, the opcode that we are going to see, that can only be this and this corresponding to add and subtract.
That you could do, yes. So
then,
even with the ever assertion, see, that is what we are doing in task C, okay?
Yeah.
So therefore, that is more targeted. So when you unwind it with particular thing, lot of the other ones should disappear, okay? Because with of course you will still have to unwind. It's only after the simplification. There'll be some simplification that is done during unwinding. How many of that will will get reduced during unwinding itself? Some case analysis, expression analysis, Boolean expression analysis happens, okay, but it may not. Okay, some of them happen only after shipping it to the SAT solver. Yeah. So you could still have them, okay, although your instructions are specific, okay. Some of them, if they are, the case is saying, oh, if the opcode is this, and then you can tell if the opcode is exactly that, then it may, then it may not. But the saving grace in the other thing is, certainly in task C1, you're only doing one unwinding, okay?
Yeah, yeah. So there, I think task C1 should be at least definitely be completely
Yeah,
fine.
C2, it depends on how many instructions are there. Yeah. But
Yeah.
that also you could simplify by making assertions, intermediate assertions after every 3 instructions or so. Okay. And then you can check them and then take away those instructions and then take three and so on. Okay. 3 at a time or anything else. So some of that you have control over. So since 3 unwindings do work, correct?
Right. Yeah. So 3 or 2 or whatever it scales up to basically.
Yeah, that is there. Now, for the first 2 tasks, what if we, to make some meaningful experience for them, okay, that is my goal. Okay, that should be our goal. Yeah. So I thought that maybe if you restrict to handful of assertions.
So yeah,
say,
let's say that we have one assertion. Like we're taking one assertion.
Okay, let's
coming back. And then let's also say that like inevitably we'll have to basically restrict the number of instructions that we're going to have. So let's say that we have decided that we are not going to deal with all the instructions, but rather only some subsets. Because without doing that, there is no way, it seems, right?
Yeah, but that you said that there's no use for that. Okay, it may not help in the sense they're all mingled up in terms of when you get to the macro level. Huh? Yeah, but there.
Yeah, I'm not saying that it will be completely useless. I'm saying that itself might become like difficult in a messy sense. Like it won't be difficult.
Yeah, it's messy in that you will have to dive into the code a little bit. Okay, and then you may get some that you could turn off and some you may not turn off. So I think that exercise, what you'll have to do is to pick one assertion that ever generates, say in a part which say it's for some simple add instruction or something, and see if you could do some slicing based on that.
Right. Yeah.
Or before that, what I would do is we can do this for both the first task, the second task, as well as the third one. Let's suppose that we want to check all the assertions, even the automatic programming, property agnostic things, okay, like overflow and so on. Yeah.
Yeah.
For one instruction program, we assume that the memory is initialized to particular instruction. Okay.
Right. Yeah.
And then we only need to, hopefully unwind for one. Okay. And then check whatever assertions, whether user-defined assertions or automatic ever defined assertions in one step, if all are assertion and whatever that assertions. That's all. But that is all. That is already being done, I guess. No, when you run ever, you only run it for one step. Yeah. So in ever, you only need to run for one step. Okay. So in CBMC, what you can do is you check that only for those assertions when that instruction is getting executed. That's all. Even the ever assertions.
Okay.
So then,
given say the ever assertion that we have, it's happening inside the add instruction, or in a particular branch of that which case. Then we're only going to check
the ever assertion that you're now generating. You don't make any assumptions at all about what the program is. So I'm setting PC to be particular location, assuming memory at that location has that particular instruction. Then executing ever one step. Okay.
Okay.
Checking all the assertions. And
Okay.
generating.
So what you're saying, sir, is that like we'll take one particular instruction and then generate ever warning for that, and then while checking inside CVMC as well, we'll also assume that only that particular instruction.
Correct.
Yeah. Okay. Yeah. I think that. Yeah. Okay. Sure. That might work. I think. Yeah. Yeah. So then I guess we'll have to just encode the fact that what we are doing is this particular instruction in the opcode, and
that's right. So I'm scoping down the first two tasks also to this program agnostic thing to specific code. That's all. Okay. So which means I'm saying that I'm only doing limited checking of those warnings, only for specific programs that I care about. In this case, only one instruction program. Okay. Or in general, maybe I can do for 3 instructions, 4 instructions. Of course, that, whether that will simplify. The moment you go beyond 3 instructions, it will require 3 unwindings of CBMC, okay? Whether that will work with, more than 3, 4, 5 unwindings, it depends on how much simplification you will get. With that instruction, okay, having instantiated to particular instructions being executed, okay, whether that will give any simplification or not, okay, before the SSA generation step, we don't know, okay. If we cannot, then, yeah, because beyond even verifying programs beyond 4 instructions might be problematic, okay? Maybe we will get some things. If you make it into specific things, maybe the simplification will happen. I don't know, okay? That needs to be checked, okay?
Yeah,
so
if it's stuck at SSA generation phase, then maybe it won't happen, right? Because the simplification will probably be done at the SMT solver level, right, sir?
No, that is what I'm saying. So the kind of simplification that will happen is constant propagation. For example, if you know that I is 0, if there is a check at I is equal to 0, it will get simplified to false. So the go-to program itself gets simplified. Okay, it does happen.
Okay.
So what you can do is maybe assist it. Okay, this will require again a little bit more. Okay, so assist it to that will require a little bit more understanding. So if you, by just saying opcode is equal to this, okay, some expression is equal to a constant, if it is done, maybe it will propagate. I don't know. Okay, you see what I'm saying? So helping it by saying expression, but then that will require you to understand the emulator code a little bit more. Yeah, you could say opcode is equal to, if I'm executing an add instruction, saying some bits, which expressions that those bits are equal to that particular bit or bit vector. Okay, sequence of bits.
Right. Yeah, so basically some intermediate assertions that will cut down some patches based on what the output is.
Yes. Whether even that will get trigger the simplifications at the go-to level is unclear. Okay, so that's what we'll have, you will have to do. So as an exercise, just between you two, I know that you have. I don't know how your thing is. This is exam week, and you have taken courses also, no? How are you situated in terms of those
so
things?
I have one exam, and like I have to do a project and some assignments. There's some amount of work. Yeah, but yeah, I think
what you can do. See, I can. No, but
I think I can. at least ask Chandradeep to try out a few things if he has the time.
Yeah,
But I don't know if
that is a better idea. Okay, so you can actually assign them, okay, and ask everyone to do that, okay, and then see who does that. I think Dhruv and Harsh are not doing any work, okay.
Hmm.
You know,
Okay.
Siddhant, I don't know, okay. He is working with him, but he himself is doing any work, I don't know, okay. So you could, let's make certain things, okay. So, you know, generate you, you initialize the memory to particular thing, okay.
Hmm.
Then generate EVA assertion.
Hmm.
That.
And then once that has been generated, take those assertions and try to see if CBMC
Yeah, just for
add
one.
add those extra assumes that will initialize the memory to particular thing.
Yeah, but I don't know. So they can't. You will have to specify what those assumes are. They are.
Yeah. That I'll do. I'll take one instruction, say like some add instruction or something like that. And I'll generate the opcode for it. So I'll specify that, okay, when you're generating the assertions, just, add in a statement that says that this opcode is being assigned to this particular thing. And inside CBMC, that assign statement becomes an assume statement, and then do the CBMC check with that.
Yeah, that. And then you can also do it for the same instruction, do task C1, okay, which is just, have assume that that at that the PC, I mean, at the memory location at that PC is an add instruction, okay. And the two source registers have some symbolic values, okay. Symbolic values, by which I mean, the register content is something, this register content is some bit vector. So they don't have to be specific. That's what I mean by symbolic value, okay.
Yeah, so we don't assume anything on them basically.
Yeah, but what I want is, I want to be able to give some symbolic names to them, okay. Just do some non-deterministic bit vector, assign it to them, okay. And then you, so those registers will have to be initialized also, okay, to that. So those will be the assumptions at the beginning, so that your post assertion can then be said, okay, in my destination registers, what I will have is the plus of those two symbolic constants, okay?
Okay. Yeah.
That is how I'll have to say, because I need them to be able to specify. If you just leave it arbitrary, you don't know what to check.
Yeah, that makes sense. Sure. So
that is how I intend for them to do. So this is the small kinds of things that they'll have to think and then say, okay. So, but anyway,
I'll do this one now. So the way the opcodes are arranged, there is like two parts. One is the part of the opcode that will actually tell you what instruction it is, and then you have the the most of the opcode is the argument and what register you want to. Yeah. So what I'll do maybe is that I'll just specify, or I'll give them some assumes and assignment statements and so on that will only specify the first part of the opcode, and will not assume anything about the second part of the opcode for task, the first task, the A and B basically. So that I can do like immediately right now, and then and then
for the C task, you will have to have more assumes, okay.
Yeah, more assumes on the, so for example, we have to say, instead of saying this is some add instruction, we'll have to say that, okay, this is an add instruction that is taking these two registers and adding them.
That's right. So they could be two registers, yes. So that's how you will have to do. So,
right. So I think for the first part, let's just go with some add instruction, which will be easier to encode and easier to write assumes for.
Correct.
And then we can move on to specific add instruction and taking them from there on.
Correct. Okay. Yeah. So even for the other one, what you can, I mean, you can be clever about it. Say if you can be either too specific or yeah. So that is good enough. Okay. So if you leave all the sources, etc., how specific you want to be in the second exercise, say for C1. Okay, you could say specific add of register 1 and 2. If you leave that open, that it can be any one of those 16 registers, okay, 16 registers that it supports, then what you will have is you will create 16 constants, okay, symbolic constants. And in your assumes, you will say register 1 will be register 1 init, or register 2 init, etc., etc. Okay.
Yeah, that can be done.
Then your post condition will be, oh, if my the instruction is reg 1, reg 2, it'll be this or something like that. Okay, that will be a little bit more complicated. Okay, so you will have to do
that's more
it'll be a big
complicated, right?
if-then-else analysis. Yes, yeah.
Yeah, I mean, either it has to be some big if-then-else sort of like. So there has to be some big if-then-else in the assertions and assumptions itself. And other than that, they'll also have to be like,
or you can even do that. See, in order to do it, you don't need to do. So if you can even check. It can be anything. You don't assume anything. But if the code, your post assertion could be sliced. Okay, you could be checking only one of those cases. If that code is register 1, if that code is register 2, then my destination register is a certain register, then that destination register will have the addition of those two symbolic constants. Okay, so you could slice it like that, no? Okay, instead of taking care of all the cases. Okay, so then since I'm arbitrarily choosing register 1, register 2, so you can gain confidence that the same thing should apply to other things. Okay, so these are small things. Okay, so these are limited assertions. Okay, which will gain confidence. Okay, rather than making one assertion to check the entire add instruction. Yeah.
I think slicing it would be better.
Yeah. So so first send off something to Chandradeep. Okay. I mean, you send it to everybody. Okay.
I'll do this. I'll take the add instruction. I'll take its opcode. I'll see that opcode is like behaving well with this. Like I'll just run it in some GDB and see that like at least inside GDB it's working. Everything is working as expected. And then I'll like give that opcode to them along with where the assignment and where they assume it to be added, and ask them to.
One independent expression for task C1 that I want to do is to just what we just now said. Okay, whether you want to assign it to them, maybe you can assign it to them because they need to do it. Okay, what you're saying is you may not be able to do it right away is what you're saying. Okay.
Yeah, like I don't think I'll be able to do it right away, and I don't think they'll be able to do it right away. I think we can just do this for now and then figure out that one a little bit later on.
But if we can figure it out, briefly discussing amongst ourselves, we can explain to them what that needs to be done. Okay, in tomorrow's class.
Yeah, I think in terms of like what the task will be, without going into what the specific opcode is, I think that we can figure it out. Like that is what you said already, right? So that is that we'll have this add instruction itself. Let's say that, and we'll have a few different versions of it, maybe, or one version of it. Yeah. And say we'll take one of those versions. We'll try to actually verify the semantics of it in some sense. Like we'll say that.
So basically, all our verification is now limited to memory being initialized to particular instruction, and that being executed only one instruction. Okay, and that result. That's it. Okay, we may extend that to up to 4. I mean, if this is really simplifies it somewhat, so we'll see how we can take it. Yeah.
Right.
Based on the outcome of how CBMC can be sliced. Yeah.
Yeah. Okay.
Okay. Yeah. So tomorrow also we're meeting at 7:30 p.m. Yeah, that'll be the
Okay,
last
sure.
time. Yeah. Now after that, based on your thing, we need to set a date for your presentation, man. Okay. So based on your
Yeah. So I've like made the slides, some 60-70% of it is done.
Okay.
I
Okay.
Yeah. So I'll finish it up and send it to you.
Yeah.
Yeah.
Then we need to, like we said, you will have a presentation, and then we'll have lots of comments, and then comments about how to cutting it down to half an hour, and then you will have to have one 20-minute presentation too. Yeah. Okay.
Yeah. So I'm trying to make it compact from the get-go itself.
Okay. So that'll be good.
I'll see if I can. Yeah, I'll see if I can. Yeah. But without making it, I think it's hard for me to tell us whether it is like compact enough or not. But I'll try to make it not too big. Yeah.
Okay. Okay. All right.